In this video, we are going to talk about linked lists. We're going to build this out from scratch in Swift. Now, there's going to be an upcoming episode 2 about more complex stuff, but today we are going to dive deep into the linked list. If you're interested, go ahead and check out the full link for the full playlist, and also make sure to hit that subscribe button and notification bell to get notified of the upcoming video where we are going to dive even deeper into linked list. And also there's going to be a doubly linked list after that. So today, singly linked list, the basics, but really, really deep. And if you want to book a call with me, one-on-one session, maybe about Swift, Swift UI, or algorithms, data structures for that matter, go ahead and check out rebeloper.com. Is the first link in the description. Okay, so what I did is just prepare the playground right over here. And let's talk about linked lists, what they are. So previously we talked about arrays and then stacks, which are kind of arrays under the hood with some limitations. And they do have the time complexity and space complexity of the arrays too. But today we are going to talk about linked lists and their advantages and sometimes disadvantages. What is actually a linked list? Well, think of it like this. Let's just have an array right over here. So we just say 1, 2, and I just have 3 over here. So this is basically an array. So we have 1, 2, 3. It is contiguous, so it's one after the other. So this is going to be stored in memory at one after the other slots inside your memory. So 1, 2, 3. Now, if we don't have enough space, we're going to search for a bigger space in memory and so on. Also, we talked about dynamic arrays in the previous video on the arrays. So we need to actually find twice as long, so we have dynamic arrays. That's what arrays are under the hood by default in Swift. Now, what are linked lists? So linked lists is a little bit different. Let's say we don't have that amount of space, and but we still want to store it. So we just say it like this. So we have 1, 2, and 3. So there is this arrow. That is the pointer. So we would just have 1 on a memory slot, let's just say, and then the memory slot number, the address that is pointing to number 2. So 1, and right after it, we have the pointer, the memory address that is pointing to the second element, which is 2 right over here. And then that could be anywhere, by the way. It doesn't have to be contiguous. It could be, but it doesn't have to, and usually it is not. So it's pointing somewhere else in the memory. And then we have 2, that's the actual value, and then another pointer to the next node. That's what we are calling these nodes. These are the nodes, and these are the pointers. And the pointers are basically the addresses of the next element in memory. So we have 1, and then pointing to 2, and then that is pointing to 3. And that is basically a linked list. It's a singly linked list, meaning that we have only one pointer, so it's pointing to the next one, to the next, and to the next, and all of that. And by the way, we are also pointing to nil right over here, which is, it's kind of complicated under the hood, but basically memory has these specifically reserved memory places where nil also lives. So our compiler knows that, okay, we are pointing to a nil value. The linked list just finished. And, we usually don't care about this part. We are going to do that in code. You will see that it's going to be nil at that point. Now, this is the head, and this is the tail. So the tail's next node will always be nil. Now, of course, if we have only one element inside our linked list, just like this, then the tail equals the head, which means the head also is pointing to the nil next node. But, usually we're just describing it like so. Okay, so that's the whole analogy and how linked lists work. There are numerous ways that we can use them to solve algorithms. So we are going to build one today because we don't have that in the standard library. We have arrays, we have dictionaries, we have sets, but we don't have linked lists. And you could also create double linked lists, which we are going to do. Go ahead, make sure to subscribe to the channel to watch out for that. But we don't have stacks, we don't have linked lists. We created a stack in the previous video. Now we're going to create our linked list. So let me just remove all of this, and maybe, just for reference, we leave this up over here. So first of all, we need to import foundation. So foundation, and let's create our linked list. You will see that I have some publics and some classes and final classes and all that. I'm building all of this out so you could just easily add it into a Swift package and use it in all of your projects. By the way, I also have a separate Swift package on my GitHub account. Go ahead and make sure to check it out. It's github.com/developer, and it's one of the pinned ones, Swift data structures, yes. So let's create our public final, so we don't mess around with it. It's just final. We can't initialize it outside of scope. It's just going to be final, and we're going to create a class. And you might be tempted to just go ahead and start with the linked list, but no, we are going to actually create the nodes. Remember this part. So this part, including the arrow, the pointer to our next node. That is a node, what I just highlighted. Class, and I'm just going to name this LinkedListNode. You could just name it node, and in some tutorials it's just named node, but it's what type of node. We are going to talk about also doubly linked list nodes, so just linked list node. And it will have a value. Now the value, we're using generics right over here. It could be anything. In our case, we just have an int value, but it could be any type. Okay, let me just move this a little bit further down so we can see it a little better. Great. So what does a node has to contain? Well, it has to have a value and that pointer, that reference to the next node. So I'm going to make that also public var value, and that will be our value. And then finally our public var. We're always going to call this next, moving to the next. When we're going to talk about doubly linked things, there's also going to be a previous, like pref, but for now, it's just going to be next. And that will be a linked list node, and it's going to be optional. Remember when I talked about the tail right over here? On that end, the actual next is going to be nil, right? Or if, the tail actually, it could be the head, by the way, if we have only one element, but the tail always has the next as a nil. So let's create our initializer. It will be internal, so you cannot mess around with it outside of scope. Init, and let's just see if it completed correctly. We have a value next. By default, it's set to nil. That's great, and we are just assigning. Okay, so that is our linked list node. It is a class, final class, and of course it is public, so you can just use it as in the Swift package manager. Now, in the previous video, we talked about stacks, and I talked about how you can print it out so it looks a little bit nicer, not just an array. We also have that CustomStringConvertible and CustomDebugStringConvertible on the linked list node. I'm not going to waste time. This tutorial will take up a lot anyways. I'm just going to copy and paste and just go through it really briefly. CustomStringConvertible needs to adhere to the description, and if we do not have, actually, if you do not have a next value, meaning that this is the last one, the next value, the next is nil, we are going to return just the value inside the string, free, right over here. Otherwise, if this guard is not going to, so if next is not nil, then this is what we are going to print out. The value and the arrow, and then this string describing, the description, the next, and we just go over and over and over and over again. So you will be printing out something like this, well, exactly something like this. If the linked list has 1, 2, and 3, and they are pointing in this exact order. Now the debug description, the same thing, but we are using it for debugging purposes. This is mostly for developers, and you can use debug print if you want to, and also the debugger and all of that stuff. This is just for end users. Real quick, for the print statement, the debug description is for a more detailed analysis. Okay, and I just copy and pasted that inside so we don't waste any time on that. Okay, so next up, we want to create our linked list finally. Let me just have a little bit more space. Let's create our public struct, not string, but struct, linked list, and it will have the value, not val, but value over there. Great. Okay, we are going to add some properties right over here. And those properties are, if you remember, we have a head and a tail and some other is empty, and all of those functionalities that we might be interested in. Now, before we jump right into it, we are going to have to talk about how we are going to manipulate the linked list. So we are going to actually push, so put, let's say, 0 over here, just like that. Or we could also append, like 4 over here. So those are kind of the additions. Or we could just add in here a new value, like, I don't know, 5, whatever. Doesn't really matter. It could be 2 or anything else. So this is how we add in, and then we could just simply pop. That's how we remove the header, or we could remove the end, or we could also remove after a certain node. And basically those are the main functionalities that we are going to build out today. And for that, we also need to track some stuff. So let's just add our public head and tail. So public, we are going to set it in private. So we are going to also set private set. Basically, this means that we can access it publicly, but we cannot set it publicly. We cannot set it to only private, right over here. So head, that is going to be a linked list node of value, and optional, because you might not have any elements inside your linked list. Therefore, the head will be nil. And let's duplicate this because it's the same thing for the tail. You might have a head and some other elements, or none. And you might have, if there are any elements inside your linked list, you're also going to have a tail, the last element inside your linked list. Now, these could be the same at the same time. If we have one element, the head is exactly the same as the tail. But, it could be also a nil. Okay, so those are one of the most important variables that the linked list have to have. Let's create our public initializer. So, it could be accessed outside of your Swift package if you're going to put that. So public init. Otherwise, we cannot access the structs initializer because it will be internal. So we are making it public right over here. Okay, so next up, let's do some convenience stuff. So first of all, is this list empty? So public var is empty. And this is going to be a Boolean, of course. And how do we know that our linked list is empty? We know that because when our head is equals to nil. As simple as that. Okay. Next, we are going to, in some cases, we do need to know the count of our linked list. And if we want to count it, that will be a big O of n. So time complexity, because we need to go through each and every element inside the linked list. So because it's not contiguous like the array, we cannot store indices. Therefore, we need to traverse the whole linked list. Therefore, it is O of 1. But we want to get only the count. We don't care about the values. Therefore, when we need the count, we are going to grab the count that I'm going to write right over here. And with the functionality, we are going to update this count so it reflects the actual count in the linked list. So again, a public private set var count of type int, and default value will be 0. Okay. And in some cases, you just for a quick reference, you want to grab the linked list's first value, not the node, but its value, or the last, the tail's value. Now, this is really great. For the head value, it's big O of 1, is the first one. You can just grab it in constant time. But the tail's value, again, it's O of n because you need to traverse the whole linked list to grab that value. So it's great to just store it inside this variable. So public var first, it's of type value. And of course, it could be optional, if it's nil. We are going to grab the head. This is optional, so we have the question mark and then value. And let's duplicate this line to be the last, and that will be the tail's value. Okay, so these are some really good improvements of life variables that we're also going to use along when we are going to create our functionality. Now, the first one is to push. Remember, I talked about pushing. It's just going to put an element just right over here, a node. We're going to push it as the head. So now the 0 is linking to 1 and 1 is linking to 2. Previously, 1 was just the head and then it was linking to 2. So let's create that functionality. Oh, by the way, before I forgot, let me just add in the CustomStringConvertible extension and the CustomDebugStringConvertible. So we can just use that right off the bat. Again, if the head is nil, then it's an empty list. Otherwise, string describing the head because it's a pointer and it's just going to go string describing, string describing, string describing, the node, the node, the node, node. And we're going to get something like this. Okay, great. So now let's just talk about how we can push. Yeah, let me just scroll a little bit up over here. Yeah, after, well, not the linked list. There we go. Scroll down, actually. What we are going to do is create a public mutable function, mutating func of push, because we are going to mutate our linked list. And we're going to add in a value. So we're not adding the node itself. We are going to add in a value, like an int value or anything that the type might be for that linked list. And then we are going to return back our linked list node of that type of value. Now, in some cases, we might not actually care about what that type is. So I'm just going to go at discardable result, append it right over there. So in some cases, we don't even care what the actual node, the created node from that value, the push value is going to look like. Okay, so what are we going to do? Well, as I told you, we are creating an actually new head with that value. So let's just add head, the property that we set up right over here. This is where it's actually taking reference for the head. Head equals linked list node with value and next. Now, this will be a little bit confusing. Let me just make even more space over here. Because we are going to add in the value, of course, value. Now, what is this next? The next would be this node, actually, right? So what is the next node at this particular moment in time? Well, actually, it is the head. Now, this might be confusing because what we are assigning to head with the next of head. Well, think of it like this. in Swift and in many programming languages, we first evaluate the right-hand side of the equation and then assign it to the left-hand side. So at this point in time, the head is still the old one, right? One right over here, the old node. And then we create this new linked list node with the value as the head, the old one, as next, and then we assign it to head right over here. So now we just updated it, and this is going to be 0 in our case, and then the new head will be this node with a value of 0, and the next with the node with a value of 1. And finally, we want to return what we have created. So we are going to return what did we create, our head. So at this point, because it's optional, we can just safely hit that bang, the bang operator, because we do know that we created our head. Now, this is how we just push, we just add to the head. Now, one other thing to note is that we are also going to need to count. So remember, we have this count right over here. So right before actually we return the head, we want to add in the count. Now you could just add it right over here. So count plus equals 1. But there's a better way of doing this because, this is simple code, but in other cases, you might have more complicated codes, and you will see later on in this series for the linked list. So what is more preferred is to just add a defer. Now, what does the defer do? So I'm just adding defer count minus 1. What this does is, okay, just do everything, including the return, but before we return, do this part, the code between the deferred two curly braces. So go all the way in, and before you close this function, in our case it's returning, before that, do the defer. And usually you want to put the defer in front of your, on top of your function, because it's much more readable and all of that stuff. Okay, so that's how we push. Next up, how do we append? So let's just create another public, and let's just test it out before we move further. So I'm going to add it right over here. So let's create a variable called linked list. It will be linked list, come on, of type int. Okay, great. And then we are going to say a linked list dot, and then we are going to say push with a value of 1. And then let's just print it out. Print linked list. Okay, I think we need to tap on the build right over here. There we go. So 1 has been printed out. Please note that there is no error. So let's copy out these 2 lines and add a little bit more. So 2 maybe over here. Let's build again. And there we go. We printed out this linked list, and then 2 and 1. Now, please note, we are pushing. So this 2 is actually added right in front of 1. Good stuff. Okay, so what I'm going to do is just comment this out. And let's move on to our next functionality because we are already big on time. I think I'm just going to chunk these into more separate tutorials. Next up, we are going to append. So we're going to make a public mutating function of append, a value of value. And then what are we going to do? Well, let me just have a little bit more space over here so we can see it a little bit better. Okay, so what we are going to do is just add to the end. So just like this. What we need to do is just update the tail. So what we are going to add in here is tail exclamation mark, because we at some point, we are, well, let's just go with the question mark for now. We are going to bang it out in just a second. But tail.next equals that new linked list node. So linked list node with the value, and we're going to go with only the value, not with the next, because this is going to be the new tail, and therefore the next is going to be nil, which is by default with this initializer. So value, just right over there, value. Oh, come on. There we go. And then we are going to set, or rather update, the tail. Let's just see. Oh, sorry, wrong. I just put it into the extension right over here. There we go. So we are going to update our tail after that. So we just set up the next. Now tail is actually not going to be the tail itself. So we are going to say tail equals tail dot next. And you see it just automatically added in our question mark. But at this point, we actually do know that that tail exists, right? So how do we handle this part, the question mark? Maybe we don't have a tail. Maybe it's just empty. Well, if it's empty, then, the linked list is empty, then append actually means push, right? It's just going to put in our first element. So we want to make sure guard that is not empty is empty. Else, we are going to, first of all, return. We're not going to go through all of this. Therefore, we know that it's not empty at this point, so we can just add in our bang operator. If it is empty, then we're just going to simply say push our value. There we go. And it's that simple. Now, one other thing, we are also bumping up the count. So what I'm going to do is just copy out the defer. And where should we put it? Not over here, because maybe, it's just going to push because it might be empty. And then the defer is going to be added twice. So we are going to count twice. So because the push already takes care of the count over there, we are just going to add it right over here after the guard statement. So it's just going to go through these lines, and after it finishes, the function is just going to go through also the defer. So we're just going to bump up the count by 1. Now, the next one, it's a little bit more complicated. We are going to insert an element, but for that, we are going to wait for our next tutorial. So make sure to hit that subscribe button, hit the notification bell, maybe like this video, and I will see you in the next one.